All right, you guys, we're on our last data analysis lab. This is the ANOVA lab. And after this, things get much easier. This chapter has 6 worksheets and this lab. And nothing difficult about this. You just want to be able to think through what the logic of it all is. All right? So I'm going to give you an example of what you're going to be doing in your 2 different one-way ANOVAs that you see here in your instructions. And so we're going to be going into our, well, here's my data. I'm going to use exercise, meditation, and diet as we look at stress. So we would have scores on some kind of graded. I just made these numbers up and then thought of 3 categories. So really just to show you how to do the data analysis. But the logic of it all, you're going to have to figure out on your own. Okay, so let's pretend we're comparing these 3 groups, and we want to do a one-way ANOVA because we have one factor, which is techniques for reducing stress. All right? So we're going to go to our data analysis up here. Now, if you don't have that, you need to load the add-in. So go back to our correlation and regression chapter, and I put another link to that, how to do the data analysis add-in, and watch that first. But we've got it here, so we're going to click on it. And at the very top are the ANOVAs. So our analysis of variance, we have a single factor, just one factor here, and then we're not going to use a 2-factor. We would have a 2-factor if we used exercise, meditation, and diet, and one of the groups was males and one was females. So then that would be a more complex analysis. So we're going to do a couple of real easy ones here. So we're going to go to OK. Oh, well, look at that. Let's select all of this. There we go. And then notice it says, that's my input range. And then notice it says, is your data grouped by columns like it normally is, like we see over here? Or is it grouped by rows? Because otherwise it's going to think I have, what, 10 groups of 3 instead of 3 groups of 10. All right, and then I covered up the labels up here. If I hadn't, I wouldn't need to click this, but I did. And then alpha at 0.05, that's our normal default, so we're going to use that. And then my output range, I'm going, yeah, that's a good spot because the output's going to be right next to my data. We don't want to use the default, which is a new worksheet, which would show up down at the bottom. All right, so that's the upper left-hand corner of the output. Let's see what we get. All right, now isn't that so much easier than when we do it all by hand? Let's see, can I see all the numbers? Yep, there we go. All right, so now what do I have here? Here's my ANOVA table. I've got my between group sum of squares, and I take that number and divide it by my degrees of freedom between, and I get my mean squares between. Then I do the same with my within groups. I didn't have to do it this time. It's doing it for me. And then it takes this, divides by that, and what do we get? We get 23.09847. All right, so looking over here at our instructions, the first thing we're going to have to do is come up with whatever the null hypothesis is. Let me just get rid of that real quick. So the null hypothesis, I'm sorry, that's my dentist calling. Okay, I'm going to let that go. I apologize, you guys. So we need to figure out what the null hypothesis is. And the null hypothesis here would be it doesn't matter which group you were in, you had the same stress level or same change in stress level. All right? So I'm going to state my null hypothesis that there'd be no difference in the groups. At this point, you want to probably take your table here and transfer it over to a Word document. And then you can write underneath it what your null hypothesis is, and then report the results. And this is the way we're going to report the results. We're going to say F, and then we're going to put our degrees of freedom between, and our degrees of freedom within, and F equals, there it is, let's say 23.1 ought to do it. And then I'm going to report my probability. Now I don't have to talk about greater than or less than 0.05 because it's going to tell me my exact probability, and that's what I'm going to put here. Now take a look at this p-value. I put this one in here on purpose to make sure you recognize the exponential notation. So when we have the e minus 0.6, that means we need to move the decimal place here to the left 6 places. So that means we would move it to in front of the 1 and have to add 5 zeros. So our value for p would be 0.0000142. Well, that's almost nothing. So what does that mean? What does that mean about the null hypothesis? What does that mean about this particular set of data? Because remember, P is the probability you would get this data if the null hypothesis were true. So the probability that null is true is pretty low. So in this case, we could reject the null hypothesis. And then the third question, what could you tell a lay person? That's the tricky part. If we can reject the null hypothesis, that means we can say something significant happened. But it doesn't mean that the alternative hypothesis is proven correct. So we just need to be careful how we word things when we're explaining what we see. In this case, we see a very significant difference between the three groups. All right? So then you're going to do the second one and do the same things, and then get your 2 ANOVA tables, your 2 answers to the 3 questions beneath each one, all on one page, on a Word document that you submit to the Dropbox. That's assessments and then assignments. And get it in by the deadline. So all you have this week is 6 worksheets and these 2 very easy ANOVAs that we're going to do. All right, and I will see you soon. Bye-bye.